In listening to the other speakers, and I know the theme of the meeting is to be skeptical, I think that what I'm talking about here this afternoon is more of a conservative, quiet optimism about exercise and physical activity. And this has really been an area that I think in the past people have been more skeptical about. It seems that with, I'll say, the good science that's been conducted over the past 20 years, and that primarily has been through the NIH funding, which more than 20 years ago, most scientists and probably program review officers would have dismissed physical activity and exercise as relatively trivial. What I would offer to you is it appears that it is not a cure-all. In fact, you can certainly overdo it and cause problems, like arthritis. But at the same time, it appears to be probably a very promising form of preventive medicine. And what I'd like to do is run through the slides. If there's time, we might also, time permitting, we might get to something that's highly related, but separate and distinct, which is the athlete and the notion of this so-called zone or high performance state. And some of you may have even heard of this topic of the 10,000 hours of practice and we can become experts. And I will tell you that is one thing I do not agree with. And I believe that is a myth. And sometimes I say my opinion, and 250 will get you on the metro, but it is my opinion. So I'm going to talk about exercise, physical activity, and maybe realistically what we can expect from it. And as I say, if there's time, we'll go into the athlete. By the way, as I go back to this first slide, this Department of Kinesiology, it's somewhat of a misunderstood field, I think. It grew out of a professional offering, which was physical education, which I would say is related but quite distinct now. The kinesiology is really the science and the scholarly study of movement. And one of the things I'm going to be talking a lot about this afternoon is Alzheimer's disease. And I will tell you that myself, 10 years ago, I was quite skeptical of anything as freely available as physical activity would have any relevance to any kind of prevention or attenuation of something as fearful as Alzheimer's disease. So again, an area of ours grew out of this study of movement, and now we just recently joined a school of public health. They actually, primarily at University of Maryland, primarily built the School of Public Health around us. And kinesiology, or the study of activity, has not been part of public health, but I think what you're going to see as we move forward in the century, it's a reasonable bet to say that physical activity will become central to public health. Now, I start off because the flavor, there's so many different areas of physical activity you could talk about this afternoon. We could be up here for 3 days. I put this old ancient Greek statue of the discus thrower, and above it I put mens sana in corpore sano, which is actually Roman, even though the statue is Greek, for a healthy mind within a healthy body. I think that there are a lot of people maybe who cheerled that to be kind of a falsity, but the fact of the matter is the ancients were onto something that some of the best researchers around the country, I see a Kansas University t-shirt back there. In fact, some of the best research I know right now on physical activity and Alzheimer's disease is being done at the University of Kansas Medical Center. The technology we have now with neuroimaging and looking at proteins in the brain actually would tell us that that old ancient philosophy had a lot of truth to it. I put down this concept up top to give an overview, and then what I'm going to do within a couple of slides, I'm going to go to the Alzheimer's disease to give us something at least solid this afternoon to hang on to, some structure, and then we can kind of open it up for some general discussion. And so I've got some concepts up here, and let me run them through to give a flavor to the talk. So I've put this topic up called, this phrase up, exercise is medicine. Now this is actually a concept through the American College of Sports Medicine, the American Medical Association. They've actually partnered and they have this initiative called Exercise is Medicine. And at this point in time, it's just getting off the ground, but it's probably going to be something that is not only within public health messages, but probably also even starts to guide political, or I shouldn't say political, I should say policy guidelines and investments at the local and at the state and probably even at the national level. An investment in such things as the design of communities where people need to move. As some of you in the room may know that city dwellers usually tend to be more physically active than suburbanites. And that's not hard to determine. The reason for that is simply what? Suburbanites use what too often? The car. Right, you walk from the front door to the car and turn on the ignition and that's it. A lot of times I think Americans get a very bad rap for being obese and lazy. I would say Americans, I'm Canadian, so as a bit of an external observer, I can tell you, I think Americans are the hardest working people I've ever seen. What it is with what we've done, particularly after World War II, with our infrastructure, with the design of our communities, we don't have to move. That doesn't mean we're lazy. In fact, we often think of the noble caveman as they were out there running around with their spears and being very physically active. I would bet you that most of those cavemen and cavewomen, probably now, if they had a 50-inch plasma and a Mercedes sitting outside and a refrigerator where you've got everything in the world within 20 feet, they probably would put us to shame. They probably would say, I'm never moving again. I don't think we're lazy at all. I think what we have is we have an infrastructure around us that doesn't really force us to move. But it's interesting, I was in the airport the other day. I had to go to a meeting called American College of Sports Medicine out in San Francisco. I had to fly through Chicago. And many of you have probably noticed this. We also have, though, driven within us, I think within our DNA, a tendency to be efficient. You look at the escalators and you use the stairs. Very few people take the stairs. In fact, I take the stairs and people look at me like I'm crazy. Or the moving walkways. Very few people go off to the side in that. I'm not so sure that that's really laziness as it is. I think we kind of evolved in a world where we were very much challenged to move, and it helps us for our energy balance to be driven towards efficiency or economy. How many people, when they go to the grocery store, bring their bags out to the car like this, right? They don't have to have a course in physics or mechanical engineering to know that this, where you reduce the resistance arm, is more efficient. I think we're reasonably driven to efficiency and economy of movement. In fact, great athletes, when you watch them move, how would you describe their movements? Typically, it's graceful, it's fluid, it's economical. In fact, there's almost a bit of a juxtaposition. They're explosive but graceful at the same time. So I think the body is driven towards economy. The problem is now we've engineered our society in such a way that we don't have to move very much. So with our drive towards efficiency and with the fact that we can be very sedentary, we lean that way. But I don't think it's because people are lazy. In fact, I think very simple engineering changes within our environment can have profound changes on public health. Now, here's another thing. I put down investment hypothesis, all right? There's that old notion of use it or lose it. That is probably true in many domains, such as cardiovascular fitness and musculoskeletal fitness. But as I go into some things about the brain today, it may very well be that, for example, activity at one stage of life, such as childhood, when they're 6, 10, 12 years of age, and even midlife, it may be that there are structural changes occurring in the brain. We call it the scaffolding, the white matter, the tracts, the engineering of the brain, so to speak, through critical stages. And if you want to go into something more concrete, like the bones, children who are physically active have better bone mineral density than those who are not physically active, and that's a critical period. It's like investing in the stock market 30 years ago versus investing right now. Your return is going to be greater with a critical period that has a long period following it. So the investment hypothesis is the notion that we actually may capitalize on certain changes that occurred in our body early, later in life. And I'll go into something about this a little bit later. How much is enough? Because you can sit there and say, what's he talking about? Well, the American College of Sports Medicine, which is a fairly large organization, it's been around since the early 1950s. It's based in Indianapolis, Indiana. Physicians, PhDs within kinesiology, probably about 20, 30,000 members. It's largely, I don't know if I'd call it a policy arm, but it comes up with recommendations based upon science, all right? 150 minutes per week. Basically, what you are talking about to get good health benefits. And as far as health goes, there may actually be a plateau. If you go beyond that, you're not going to get much in the way of health benefits. Now, if you're an athlete, that's a whole different story. Athletes have to be driven at high levels of challenge because they're going through specific adaptations that are relevant to performance. What I'm talking about this afternoon, unless there's time to get to the athletes, is really what do we need for reasonable cardiovascular health, the aging of the brain, etc. 150 minutes a week, basically you can think of boils down to 30 minutes of walking at the end of the day from the office. How vigorous should it be? I would say we can talk physiological terms or we can talk common sense. Common sense would be brisk walking. Because basically you have something called heart rate reserve. It's the difference between your resting heart rate, such as you're in right now, and your maximal heart rate, which even though there's great variation on this, a rule of thumb is it's the number 220 minus your age. There's a lot of variability on that. But that heart rate reserve is the difference between your resting and your maximal. So if you took a 50-year-old woman or man, then theoretically, by that rule of thumb, they should have a maximal heart rate of 170. And if their resting heart rate was 70, then the heart rate reserve would be 100 beats. Usually about 50 to 60% of that added on to your resting heart rate would be considered a healthful challenge to the cardiovascular system. So how much is enough? You know, I put down brisk walking. Now swimming, I mean, as long as there is that kind of cardiovascular challenge, could be swimming, could be cycling. The reason why walking's a good one is because it's weight-bearing. And because it's weight-bearing, you get more bang for your buck. But if you've got significant arthritis in the knees or whatever, then do the upper body cycling, you know, with the arm ergometer, or go swimming. But basically, brisk walking, which most people can do, I will tell you, after 30 years of being in the business and realizing I really don't know much, but I don't know why you got me up here this afternoon, Chip. But I tell you, after 30 years of being a professor at Maryland, and then prior to that with graduate school and everything, of course, none of us know it all by any stretch of the imagination, but I would tell you that my opinion is that brisk walking is probably about as good a medicine as we can get out there. And we'll go through some evidence, at least on the brain on that. Now, well, hopefully we can come back to some of these things before I get into my main concentration on the memory and the Alzheimer's, but I put down about myths like, such things as muscles to fat. People who get very highly muscled in that when they're younger, are they at a danger of getting fat? Well, the answer is absolutely not. In fact, what probably can happen with many of people like that is that they don't have the time to work out with their responsibilities as they get older. And they also may have been a person who had a large appetite to go through that kind of training. But muscle and fat are two different tissues. If you're well muscled, chances are you're actually going to have a higher basal metabolism. So there's no danger in terms of that kind of thing. And I don't even know if anyone in the room had that kind of notion. But to start off with a couple of general things. Spot reduction. Spot reduction can't really be done, although sometimes you find that the science will tell you that there may be little possibilities, like if that certain parts of the body, like around the stomach, whatever, if you are particularly interested in losing fat there, generally speaking, you're going to lose it off the entire body. You're not going to lose it in any one particular spot. Do we live longer? I think, they did studies at Harvard University some years ago about former athletes not living as long. And I think that kind of put a sense out there. There was even a theory called the limited heartbeat theory, that we're only given so many at birth. And if you spend them too quickly by exercising, you're going to run out of them. That's a good myth. So maybe I do have some myths here this afternoon. The best, that is, the evidence is not supportive of that. In fact, yes, I'm sure a lot of people do. And I know also, my mother, who passed away, was born in 1920, and it was of that generation that the best way to look after yourself is to rest. You need to lie down, dear. You need to rest. A man your age shouldn't be doing that. And I tell you what, once we stop moving, all kinds of problems start to occur. Because as we lose that muscle integrity in that's one of the things that really helps with the circulation and takes the load off of the heart. An undue load on the heart where the demand exceeds its capability can result in a cardiovascular incident. We need to move, but we don't need to run Boston marathons. We just need to move. I put the name up here, Blair. That's Steve Blair, who's now at the University of South Carolina. He was at the Cooper Clinic in Dallas, Texas for years. Steve is an amazing presenter and extremely humorous. Bottom line is he has very good epidemiological evidence, profound epidemiological evidence that moving and being reasonably physically fit, you do live longer. In fact, people who can be very much overweight but who still move show superior health indicators than people who are lean and thin but don't move very much. The latter might look good. They are not as healthy as the ones who are big who move. And I think that's somewhat surprising. Stroke. I put concussion. I have concussion and I have stroke. We have very good colleagues at the University of Maryland at Baltimore who are doing some very nice work in this area. There's little known right now, but the evidence is promising that moving, getting people on treadmills and they walk and they move, can actually help with the blood flow to the brain, which, depending upon the nature of the stroke, may be restorative. Then again, the specifics of the stroke could be such that the changes that occur in the vascular system and in the brain with moving are irrelevant to where the injury in the brain is. So that way you can get people saying, yes, it's good, and others saying no, and there seems to be all this confusion. It would depend upon the specifics of the stroke and whether the changes that would come from moving the arms and legs would be specific and would be relevant to the areas of the brain that have been damaged. But as a general construct, it's promising. The concussion, and by the way, one of the things I'll get into this afternoon is how moving causes and I have some pictures, so my slides will get a little bit more interesting as we go along, but I just wanted to give this as a general lay of the land. With concussion, one of the reasons that exercise may be helpful, but the timing is very important, You wouldn't take a concussed individual, whether it's from a military accident or an athlete, and get them moving and exercising right away. You would not. But after a certain period of time, it could be 4 weeks to 6 weeks, moving can actually help to heal the brain. Because one of the things I'll be talking about this afternoon is what's called a neurotrophic effect. It means like a brain nourishing effect. And why the heck would it be that we move, it would help our brain? I have a theory on that I've talked to one of the top people in the country about. You'll see I'm going to go over some work by an individual who's the head of the Brain, Aging, and Dementia Institute at UC Irvine. His name is Carl Kottman. And I've had, nobody in science knows for sure why the exercise and moving around would actually cause a growth in the synapses and the connections in the brain. But the evidence is there that it does. And I'll talk a little bit later about why that might be, and I think you'll find it'll make a lot of sense. The brain and the muscles are very much connected. But that kind of neurotrophic effect and even that vascular type effect could be good for a concussion. And this is something that's important to the Department of Defense. Could it be with the soldiers that we see over at Walter Reed? Could it be that putting them on a structured exercise program may actually help them to recover from this terrible loss of memory or executive function, depending upon, how that concussion has hurt the brain. You look at the athletes, by the way. I heard yesterday on CNN, I think that there's 2,000 NFL players now going to sue the NFL because of their concerns about concussion and how they were not properly handled. So concussion is big news. I don't know about the physical activity profiles of those athletes. Now, obviously, when they put themselves through training to play professional football, that's not for their health, right? That's rigorous, that is demanding, almost punitive type training that they go through. But I will tell you that within the general public, there may very well be a role for the restorative effects of physical activity on concussion, and that'll become clear as I go through my other slides. Now, I'm going to come back to the diabetes I've listed here, but I will tell you, anxiety and depression, the evidence is strong. The evidence is strong that physical activity reduces anxiety, both acute anxiety, like being fearful right now, and chronic, as well as depression. And you might say, well, maybe it helps these things because you're in a social situation when you exercise and the person gets out of the house. Yeah, that probably is true. But the research even shows that when you put people in a closet all by themselves, maybe it's even a dark closet, but when you put people without any social stimulation and you put them through repetitive movement that affects the homeostasis, it gets the heart rate up, it gets the blood moving, that without any social stimulation whatsoever will also reduce depression. The reason that it may influence anxiety is on multiple levels. It's probably a 3-ring circus. For example, we are not very efficient machines. We produce a lot of heat when we move. Now, if we're in certain environments, it's not that noticeable to us. We can dissipate the heat through convection, conduction, etc., sweating. But we're not very efficient machines. And when we produce heat, it's just like if you took a sauna or if you took a hot shower. What does that do to your overall physical relaxation? And this can be explained. I don't want to burden you with a physiology 101 this afternoon, but I will tell you that the heat, the thermic effect of exercise, has an impact upon muscle tension. And that muscle tension then reduces the feedback to the brain, which can have a calming effect. Also, most exercise that people do in order to feel relaxed is rhythmic. Now, and the rhythmic input to the nervous system has a very calming effect. Best common sense example I can give you of that is if you have a child who's upset. Well, there's 2 ways you can handle that child. You can look them in the eye and you can say, now look, I'd really like you to calm down. I have a lot of work to do and you're disturbing me. Or, assuming that it's still quite a young child, you could pick the child up And even without a PhD in developmental psychology, most people know to rock the baby. If you go into psychiatric wards, you typically will see people rock back and forth. Very sad, as a coping mechanism. There is an element of rhythmicity, rowing, cycling, walking, etc., that does have an impact on the brainstem. And of course, there are the neurotransmitters. What I think is, and I don't know that I would see this as a problem in society, but maybe there's some naivety that people would talk about a runner's high, where they're transformed into this state. I would say that that's conceivable for somebody who is so under stress that the release from what's stressing them to engage in a bit of physical activity may be profound to them in their own personal situation. But I really think, and this gets at the kind of the way I'd like to get across the notion of quiet optimism, is really when you go to exercise, it is simply a biological alteration. You're disrupting your homeostasis. And as you disrupt homeostasis and produce heat, and as you cause the motor centers of the brain, as it communicates with the body, it has to change its neurotransmitter levels. There are side effects. These side effects we generally interpret as good. We feel relaxed. We don't feel as depressed. But I don't know that, that exercise by itself purposefully is there for us to reduce anxiety or depression. It is through its action on the different biological systems that it has these kinds of side effects. Smarter kids, there's some amazing work being done with children at this time. Only a little bit on ADHD, because it's hard to study those populations. But with normal children, the frontal lobe of the brain, by the way, is the seat of executive functions. And this is where focus and concentration and working memory are very much major processes. The frontal lobe of the brain is the last area to develop. In fact, it doesn't fully develop until about age 28, and there's going to be individual variability on that. That's why when we look at adolescents and we look at their behavior, we might say, why don't you just shape up and act like an adult? It's unnatural. It would be like asking somebody who's 5'2" to be 7 feet tall. They can't do it, right? It's also the first area of the brain in normal aging, not demented aging, but in normal aging to go downhill. The exercise through its neurotrophic, I don't know that I'd call them profound. You know, again, when you move and you move through space, you're challenging the brain. When you challenge a system, it adapts. It usually gets stronger and therefore more resilient. You don't challenge the system, you don't get that. Children who are physically active apparently have this side effect of better frontal development. Now, the research is compelling, but it's far from complete. For example, many of the studies right now have just been done on behavior, looking to see their working memory or their focus, or they're using electrical measures of EEG, which are very superficial in terms of brain activity, but it's promising. But it makes sense. This is an area of the brain that's very plastic. It's late to develop and it's early to go downhill. It's very malleable. And so if you live a healthy lifestyle with proper nutrition and with proper stimulation, as we move the body through space and we get these vascular and these neurotrophic effects, here's a good analogy for you. We have 50 states, right? Well, there's the 51st, that's Canada. Right? I'm pro-US. Anyhow, if Washington gave $10 million, well, let's say $10 billion, to each of the 50 states, the states that are very wealthy, and I don't know that there are any in 2012, right? But let's go back maybe 20 years. Okay, so California wouldn't care much about the $10 billion, or maybe 20 years ago it did, but allow me license. West Virginia, on the other hand, may see a profound effect of that cash infusion. So what I'm saying is that an area of the brain that's slow to develop but can be accelerated, and an area of the brain that also goes down quickly, it's relatively poor compared to other areas of the brain, then the healthy lifestyle is going to have more of an apparent effect. And that may be all that we're seeing. In fact, I would offer to you, I'm not so sure that exercise is really giving us profound benefits. I think what's happening is our normal lifestyle now, that I also include, I'm chained to the desk 10 hours a day. Our normal lifestyle is probably taking us down in terms of some physical health parameters, and those that are physically active, who we believe may be leading somewhat of an abnormal life, from an evolutionary point of view, may be leading more of a normal life. I mean, modern society is a click of the fingers compared to the passage of time, right? We've been around a long time. Modern society is very, very new. And so it may very well be that what we see as these benefits of exercise are simply, that's a normal lifestyle and that's a normal level of function, but we're comparing it to people who don't exercise much. Sarcopenia is the notion of muscle loss, and exercise obviously through resistance training can help that, and osteoporosis is a problem. So there are a lot of advantages to exercise, but I think the issue becomes, what's realistic and what's the dose response, and that's where many of the questions still arise. Now, I'd said earlier, and I doubt if we will, but we can talk about it a little bit, related to this is what makes these. This is Jesse Owens. Some of you may recognize the picture from the 1936 Olympics. This is not physical activity and health. This is an individual who has talent, and because of the muscle fiber type and the kinds of training that they would go through. And I think that we can get into a lot of miscommunication when we start to think about how much activity do you need to be able to be a good distance runner or a sprinter at high. Well, first of all, you have to have many of the genetic attributes in order to be able to do this. But I'm not talking so much about that this afternoon as I am about health. So let's go into something specific, and then we can open it up for broader, okay? All right, let's start with the brain, and that goes back to my Greek symbol there, the mind and the body, and I show the little person moving. If you look at this, it weighs about 3 pounds. It's about 2% of your body mass, and it demands about 25 to 30% of the blood supply, the glucose within your body. So it's a very, very energy-hungry organ. It's about the size of a cauliflower. The neurons, the estimates differ on this. In fact, some say women have 200 billion and men have 100 billion, but I have heard that. But generally speaking, we hear about 100 billion neurons. The synapses are the connections, which means 100 trillion are the estimates, which means that there are amazing individual differences in terms of what people learn and in terms of their histories. Pretty much like snowflakes, you're not going to get any two brains really alike. I think even in the case of identical twins, the phenotypes that come from that genetic material are still going to be quite variable. One thing I will end up talking about a little bit in the next few slides, I don't know how many of you are familiar, is this structure I've got the cursor on right now, if you can see it. And that is what's called the hippocampus. And the hippocampus, the reason they call it a hippocampus, I never could figure it out for years, but you notice that it's got these little, it looks like little striped right here. It's got, get my cursor again. This area right here is supposed to look like the mane of a horse, hence hippocampus. So it's supposed to somehow resemble a horse, and through anatomy, I could never get it, but that is the gateway to long-term memory. And that area, that hippocampus right here, which we all take for granted, is why you know your children, your family, your occupation, the fact that we're in the United States, even such things as today is Sunday. This is June the 10th. This is 2012. Imagine how scary it would be if you couldn't recall those things. And so that hippocampus, by the way, is profoundly affected by physical activity and movement. But we've only begun to find that out in the last few years. And Carl Kottman, who I mentioned earlier, is a big part of that. Now, the other area of the brain, and by the way, this is the area that is a problem with demented aging. And because physical activity has a, what's the term I would do? Well, I'll say neurotrophic, brain nourishing effect on this area. That's why a physically active lifestyle may help one to become resilient. to this degeneration. And by the way, the degeneration, the plaques and tangles in the brain that affect this area are in most all of us, if not all of us. In fact, many people have this pathology to a significant degree in their brain, but they don't show any symptoms. But that's just like if the economy or if prices really rise high and you lose your job, but you've got a lot of money in the bank, you can go on quite nicely, right? Because you have reserve. And that's something that I'll talk about today, about building cognitive reserve through being physically active. How active? 30 minutes a day. I have to tell you, that surprises me, some of the benefits that are beginning to be shown. At the same time, in line with this meeting being about skeptics, before one would really take this to the FDA, there'd be a heck of a lot of more proof that would have to be there yet. It's promising, but not for sure. What happens to our brain as we age? This beautiful organ. I'm going to call it a beautiful organ. Most of us don't know that much about it, but that's really what makes us human, that structure right there. Well, we get atrophy, just like we get atrophy of the muscles, we get atrophy of the brain. You know, if we took the top of our skull off, it looks like mashed sausages in there. And those sausages, things that look like folds, those are called the gyri. And the little depressions in between, by the way, those are called the sulci. Do you know why we have a convoluted type brain with hills and valleys? Mm-hmm. It's to decrease it. And why is that important?
So when you're born,
you got some good notions in here. The ladies in the room who have gone through childbirth will probably appreciate why we have folds in our brain, because if our heads were the size of basketballs, I'm sure that birth would be an even less pleasant phenomenon. So you squish a large surface area in there. But these atrophy as we get older. And they particularly atrophy in the frontal region of the brain, which is normal. That's nothing to be afraid of. I can't remember telephone numbers as well as I could. I can't remember a string of, maybe if it was an older waiter, I can't remember the orders as well. Nothing really to be terribly afraid. That's working memory. That's working memory. Working memory is in the frontal region of the brain. It's the formation of longer-term memory, not long-term memory itself. You'll find many people with Alzheimer's disease or the pathology, they can remember things from way back. What they can't remember is what they had for breakfast, or they can't remember what they had for dinner yesterday because they can't form the new memories. That's the sign. That's the danger sign. We get a decrease in the blood flow and we get a decrease in the neurotransmitters. But the fact of the matter is there's tremendous individual variability in these changes. We do have some control over this process. And if you stop to think day after week, after month, after year of a certain kind of lifestyle, that can really make a big difference compared to somebody else who's made a different choice. Now, there are genetic differences too. I'll talk a little bit about that later. Some of us, the night mom and dad got together, were a little more blessed than others. And that's just part of genetic variation. Some people are more prone. Some people are more prone to the aging of the brain than others. Talk about a gene called apolipoprotein, apolipoprotein E. And there's a gene called brain-derived neurotrophic factor. There are differences amongst us sitting in the room here. And so some people lucked out a bit more than others. Now here we talk about evidence. Okay. This was a study that was done by the NIH. And you can see there were a few different institutes, aging, mental health, and NINDS. And this was a study called the Cognitive and Emotional Health Project. And what they want to know is, what are the factors, if you take all the big, random clinical trials and meta-analytic reviews that are really high quality? Statistician, right? Okay. If you take those high-quality, grade A knowledge studies, what's the myths and what's the truth about successful thinking and emotional health, freedom from depression, freedom from undue anxiety, things that make some people's life, very, very tough. So the goal of this cognitive emotional health project was, because this came out about 6 years ago, was to identify the demographic, biological, psychosocial factors that can help people maintain or even enhance their thinking or cognitive and emotional health as they grow older. Big public health goal, right? Because we're all going to live, probably in this room, hopefully, a long time. And what's the quality of that life going to be like? Was the physical activity protective? Yeah. Now, I don't know that these are in numerical order, but you notice number 7, I underlined the more physical exercise. So we see the higher education levels as number 1 and socioeconomic status number 2. Well, that's because there's an awareness, right? And there's probably social support. You're probably people around you who are encouraging good habits. You have an awareness. The emotional support is very important. When I was younger, I have to tell you, when I started to hear things like social support contributes to mental and physical health, particularly, I thought it was a bunch of bunk. I started out as a myth, right? Can't use bunk. I started out as an engineer and had a very quantitative mind, and I thought, how the heck could people around you have anything to do whatsoever with this biological machine that we live in? But it all has to do with perception, because as we perceive and we have a sense of trust and we have a sense of security in the people who are around us, that has a profound effect on the brain. It reduces cortisol. It probably increases what's called oxytocin, which is a neurochemical that is heightened like between mother and child. Some biosocial psychologists even believe that in groups that work together and have trust, that you have these hormonal effects. Those hormonal effects are biological. So the emotional support can translate into the biology. But the point, and you can read the others up there, but the point is that with objective evidence like walking into the courtroom, although that may not be a good objective, depends on how much you can pay the lawyers, right? The physical exercise did make it in this objective courtroom.
What's number 4?
Number 4 is mastery. Mastery is a sense probably of efficacy or competency, which I think would be tied up with fear and anxiety. For example, I live alone, but I don't know that I can make those stairs. I don't know that I can get to those cupboards. So the sense of mastery, which probably emanates from actually seeing what your body can do, again would translate, I believe, into a better hormonal state. Stress would be reduced with mastery. So a lot of these are probably tied up. Now, by the way, number 5 is an interesting one too. Better baseline cognitive function. People who have high IQ at a younger age, the brain appears to age better. Shouldn't be surprising. IQ also would be partly a function of the biology of the brain and the networking in the brain. And in a sense, it would mean that the scaffolding of the brain may be such that it has better cognitive reserve.
What's SES?
SES, I'm sorry, is socioeconomic status. The primary indicator of socioeconomic status, by the way, is not income, it's what? Education. And often tell people when I give some talks outside the scientific arena that the best investment that anybody can make in a healthy aging brain is education. Because, by the way, not only does moving have this neurotrophic effect, and by the way, the neurotrophic effect is primarily on the hippocampus. Pretty interesting. But also thinking, mental stimulation has a neurotrophic effect. In fact, it may be a stronger neurotrophic effect than physical activity. Okay, so if moving with only moderate intensity and volume has some benefits, could it really show up in terms of something which is a major public health problem? Probably going to be an even bigger one as we get older. So here's a few statistics for you. It may affect over 10% of people over the age of 65, non-institutionalized, living out there. And higher, depending upon the genotype, and the race. In fact, the genotype I talked about earlier, apolipoprotein E4, is in about 20% of us in the room. I say, well, it's not me, right? Well, and by the way, and I don't know that it does anybody any good to get tested, because some people are going to worry about it, you know? And then the worry could actually be the thing that causes the problem. Because the fact of the matter is, that gene is no sentence whatsoever for cognitive decline. It's simply a higher probability. And depending upon the lifestyle that the individual has, they may be clear as a bell, sharp as a tack. About 2 to 4 million persons estimated to have the disease in the U.S. Currently 5 million people are 85 or older. And I have 40%, but many estimates are 50% may well meet the criteria for dementia. That's a lot of people. In fact, I did the math on that one time, and it's like pretty soon the number of Alzheimer's patients will be higher than the whole population of Canada. So if you think about that, it's an abstract notion that can almost be kind of humorous, but if you think about it, it's pretty profound. Ties with stroke is the third most common cause of death, but the big thing is many of the elderly are fearful of it. I did, though, listen to a presentation one time from a professor from Harvard, and I fail to recall the name right now, but he actually was optimistic that we would find a cure for it. But one thing I will tell you with my colleagues, medical colleagues will tell you right now that the pharmaceutical companies are not doing well in terms of finding anything to help with Alzheimer's disease. And remember, what Alzheimer's disease is largely, and I'll show you a slide of the pathology in a minute, it's largely an attack on this hippocampal region, then it spreads throughout the brain. Surprisingly, at scientific meetings where they do trials, clinical trials, the exercise appears to be where you get the positive picture. But again, I don't want to stand up here this afternoon and be a cheerleader for it. It may simply be that exercise has some more broad effect than the pharmacological agents. And of course, as we all in the room know, most pharmacological agents have negative side effects. If one can do something through the lifestyle, probably better off. Here's what Alzheimer's disease is all about. So that's a coronal slice of the brain. So it would be like if we cut me in half, that my front half fell off, so you sliced me. You know, you sliced me, so just like slicing up a ham, right? So basically, the eyeballs and the nose would be looking out at you, and so you've got this slice of the individual. Now, the blue box that I drew around in this coronal section, that's this hippocampal region, and this is a preclinical state. This is almost normal, but by the way, what preclinical means is you may well have the pathology in you, but you don't show symptoms. In fact, many people at death on autopsy will show significant plaques and tangles, but have been completely normal. But that's because they've got a lot of reserve. That's because the bank account is high relative to the expenditures. What that means is that if the thickness of the gray matter and the integrity of the white matter is strong, it can suffer the onslaught of the pathology, and you can still keep on ticking. And some estimates are that 30% of individuals, and I guess we would talk about age 50 or so and above, carry the pathology in them, and that's considered to be preclinical AD. Good news is many of them may never show symptoms. They may live to be in their 90s or beyond and go to their grave and not show symptoms. But they would be classified as preclinical. So here is a temporal view or a sagittal view right below it. And you see a little blue in this area right here where my cursor's making a motion, and that's the hippocampal region. So then what happens is this is a mild to moderate case. Now notice in here in the blue box, notice that there's a gap there now. So what you actually have is the death of the neurons of the hippocampus. They are dying at an accelerated rate. And they're dying because of the collections of proteins outside, and they're also dying because of the little highways inside called tangles. To move nutrients and move substances around inside the nerve cell, which is like a long cable, the highway is getting broken down and twisted. And so eventually, for both reasons, inside the cell as well as outside the cell, those neurons are dying. And then here we have a severe case, and notice that here you see the overall brain atrophy, and you see that there's a gap here now which would be filled with fluid. And notice that the blue, it's spread throughout the brain. Now this would be the state here where you basically would be not able to recognize the children. You would not know who you were. A pretty scary state. And these are, by the way, these plaques that people talk about. Basically what you have is this protein that sticks out of the cell. It gets snipped off, and you get an accumulation. This is called amyloid protein. Every one of us in the room, myself included, is producing it right now. But you also, yep, every one of us. And then when I talk to those 18-year-olds, they think this will never happen to them, and I'm like, well, yes, you're just on your way. In fact, some of us have got a head start against you, but you're on your way. The fact of the matter is we're producing amyloid all the time, but a lot of us take the garbage out very well. We take the garbage out. We get rid of it, right? But some people don't. It accumulates. When it accumulates, it starts to block the communication between neurons. And this is the tangles, and what you can see here, you see kind of a broken passageway. This is inside the neuron. And these tangles, so these are called neurofibrillary tangles. So we get plaques, which is over here, and we get tangles, and these neurons are dying. Now, why does this come about? That's the interesting thing. To my knowledge, nobody knows why. Nobody knows why the Alzheimer's starts. And the exercise, sure as heck, is not going to cure it, but it may make you resilient that you can tolerate it. But why it occurs, I have not seen, doesn't mean it isn't, but I have not seen in the scientific literature why it's coming about in the first place. And the fact that we see more of it, I don't think it means it's increasing. We've got much better diagnosis, and we've got people living longer. Yes?
If there have been this damage like you showed in the slides, why is it people with moderate to somewhat severe Alzheimer's will suddenly have very lucid days?
Let me think about that.
You know, if it's all damaged, why did it come back sometimes?
There are different forms of dementia, and anybody who would have pure Alzheimer's, because they talk about dementia of the Alzheimer's type, there's also vascular dementia, dementia of the vascular type. Now I can see that in many cases there would probably be a combination, a comorbidity of both vascular and Alzheimer's. And it could very well be that particularly the vascular, there could be some episodic recovery. In terms of a significant case of Alzheimer's disease, I know you're correct in what you're talking about. But I don't know why you would get this clarity unless it was a form of what they call active compensation. If there was enough good brain material there that an alternative network, just like when a road has a detour, and it could very well be that somehow or other, it may be even partly by chance, right? You got a lot of connections up there. By chance, an alternate circuitous route was made which enabled you somehow to have some recollection. But I would hazard a guess that it would be a bit of a mystery to know exactly what's happening there scientifically. Here's an interesting study in a very reputable journal, Physical Exercise at Midlife and Risk of Dementia 3 decades later. That goes back to the investment. And I will simply tell you this. Yeah, I can okay, Chip. I will simply tell you this, that, well, let me just read the paragraph because I think it's very revealing. Exercise at midlife may reduce the odds of dementia in older adulthood, suggesting that exercise intervention should be explored as a potential strategy for delaying disease onset. We found that participants who engaged in light or regular exercise, and if I had been these authors, I don't know exactly what their data would show, but in the spirit of what I'm presenting to you this afternoon, I might say light but regular. I think it can be light, but I do believe it needs to be consistent. Yes?
Midlife used to be 40, but now we think it's 70. So
I believe this one was in the 40s.
Oh, so that doesn't help. Too late.
Maybe not. And so this is interesting that it shows up as a reduced odds of dementia 31 years later. Now again, this may be this notion of the investment. And let me show you something very quickly, and then we'll go to some whys and one major concept, and that should keep us on time. Here's another interesting thing. In my career, I've gotten interested in what we call the psychophysiological level of analysis. And these are things called event-related potentials. If a sound is made in the room like that, or you can think of almost like a soldier on sentry duty, and a twig breaks in the middle of the night, the brain will have a response. It's called an updating response. And we can measure that electrically with the activity of the brain. Here's an example. This is a young lady who was actually in one of our studies. And she actually, at that age there, and she was close to 90, she actually ran the Marine Corps Marathon. She probably walked and shuffled a good hunk of it, but she did the Marine Corps Marathon. If you notice, she's looking at a computer screen with a cap on her head. Now our caps are much more dense. You know, we'll have up to 256 electrodes on them. And you see an O that she's looking at. Well, what would happen is she looks at a very boring computer screen that goes X, 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 O, X, X. And she's asked to count the O's. So this is like a sudden change that's occurred in the room. And you'll see some EEG tracings here, and there's the common stimulus, but there's the target stimulus. And the brain will have, and it probably relates to survival, we have to detect change in our environment. If we didn't, we'd be caught and eaten, right? We have to be able to detect change. And I heard, in fact, somebody in the room talked earlier today about PTSD, and there is a structure in the brain called the amygdala, and that's primarily what it's for. It's to detect change and novelty, which is for our survival. And some people think that PTSD is when it becomes hyperactive, that you respond to everything. Now, I'll spare you this, but if you look at these 1, 2, 3 slides like this, and then I go back and do them again, this is just after the O is presented. This is the top of the brain. This is a high-fit older person, and this is low-fit. And the blue means not very much voltage, and as it goes more towards a yellow to pinkish color, it's higher. So just within 200 milliseconds, which is a fifth of a second, you don't see much difference. And about 250 to 300 milliseconds, not much difference, but what you see here in the high fit is you see that there's much more of a voltage response. Now, that doesn't tell us that the physical fitness is responsible for that. That tells us there's an association. That's where then you have to get into the random clinical trials where people are randomly assigned, and these are expensive, and these are hard to do. They demand medical screening to rule out all kinds of different causes. But it goes along with a lot of information that strongly suggests, and some experimental evidence, that the exercise is good for the brain. Why? Why? And this gets into my major points now. Okay, 1, we do have evidence, and some of those references are dated. I can tell you there are ones in 2012. Cerebral circulation is improved. By the way, there's a William Greenough at University of Illinois, although Bill's now got Parkinson's disease, and I think he's pretty much having to retire. He did amazing work with animals. His work with animals showed that as they move, put them on a wheel, put them on a move around a maze, compared to sedentary animals that are well fed, that are well rested, the sedentary animals, you will see improved vascularization, capillarization, blood flow through the brain of the animals that move. What, is that profound? I don't know that that's profound. It means that the animal is challenged, and the brain then has to meet that challenge, and whenever you stress a system, it's going to adapt. But better vascularization. Now, over a lifetime, it could mean that an individual might be more resilient to a transient ischemic attack, or even a mild stroke, because they have that reserve, just like with the heart. The auxiliary circulation is enhanced in people who are aerobically fit, and therefore they're more likely to be able to tolerate if there is some kind of increased demand to the heart where there's some reduced oxygen delivery. The neurotransmitter hypothesis, number 3, the attenuation of glucocorticoids is reduction of stress. The main glucocorticoid is cortisol. Cortisol will break down tissue in order to convert it to energy. So the stress actually causes atrophy or shrinkage, but it's trying to help you. Your body's not trying to hurt you. Cortisol is a stress hormone. It will shrink muscle and it will shrink central nervous system structures to convert it to glucose because it thinks you need the fuel for a threat. It's not trying to hurt you, it's trying to help you. But it's an unintended help, like, please, go away. I don't need your help. Okay, and then the neurotrophic effect, and this is a cute little cartoon I actually got from Art Kramer, who's one of the top people in the world right now on exercise in the brain. And what you see here in the slide is something called BDNF, if your eyes can see that, and that's this brain-derived neurotrophic factor. This is a gene. And that gene, what you'll actually see in the circulation is you'll see the messenger, RNA, that would cause the building of proteins in the brain. It goes up. The black is the exercising animals, and the gray is the sedentary, and you see a dose response. The more they run, the more they get. Now, this is the human hippocampus. We know in animals that this happens mainly in the hippocampus. And those animals actually learn better, by the way. Rats that are put on a treadmill that get this elevation of brain-derived neurotrophic factor, which we have in us too, they actually learn faster. How do they do that? They put them in mazes and they look to see how fast, with time, they can get through the maze. And they show superior learning and they show superior tissue density in the hippocampus. Now, if that does happen in human beings, it would hold a major implication for the delay of dementia and Alzheimer's disease, because this is the #1 target of the plaques and tangles. So the child, middle-aged person, if they were physically active all through their life and mentally active, physically and mentally active, this area may go through some hypertrophying or some increased tissue density, which would make it more resilient to the pathology and make it more resilient to brain aging. I'm going to skip that one and show you, probably got about 4 more slides. Okay? Yeah. Here we have a study that came out in 2003, which was the very first to use structural magnetic resonance imaging. Came out of the University of Illinois. Art Kramer was the senior author on this. And it was rather eye-opening at the time. You'll see a person up there getting their fitness tested for what's called aerobic capacity, or VO2 max. And basically what Kramer and his colleagues found, Stan Colcomb was his postdoc at the time, but the et al. Is then the others, and Kramer's the senior guy who's listed last. They put people who varied in their cardiovascular fitness, and these were people in their 60s, into the MRI machine, and they looked at the tissue thickness of the brain. And they found a statistical significant relationship that those who had higher VO2 max, or aerobic capacity, had thicker gray matter, particularly in areas of the brain that age the fastest. Now, that's only an association, right? But it's compelling. But now, just this past year, 2011, in the Proceedings of the National Academy of Sciences, let me show you what you have here. This is the second step that programmatically followed their initial observations. This is a year of physical activity and training. This is the left hippocampus and this is the right. By the way, you have 2 on each side. The red is the control group, and the vertical axis is the volume of the hippocampus. And what you see in the blue, these are the individuals who went through the training, walking training, trying to get them into that heart rate reserve. Again, they weren't training for the Boston Marathon. Not only did you see a maintenance of the volume of the hippocampus, but you actually saw an elevation. And in fact, I think Art was telling me that it's like 2% to 5% higher than what would be expected in terms of just maintenance. So in other words, you're actually getting kind of a hypertrophying or increasing effect, not just keeping the bank balance steady, but it's actually increasing. So there with the random clinical trial, where all things are held constant between the two groups, you see that the physical activity is having an impact on the area of the brain that is most susceptible to aging. And there would mean that you maybe you have more room to shrink. See, that's the thing. It's not that it's curing the disease, but you have more room to shrink. I'd like to give you an analogy, and then I bring to closure, I think, with this slide right here. And let me go back to here. If you had really long pants and they shrunk, you might still look pretty good, right, as you walked around in your trousers. And those really long pants would be analogous to having hypertrophy or increased thickness of the hippocampus. But if your pants were relatively short to begin with and they shrunk, then they'd look pretty bad, wouldn't they? There would be a symptom. There would be the revealing that there was a problem. So I think we have to look upon exercise as not a cure-all. We have to look upon exercise as just something that helps the body to maintain its normal integrity, but it can make you resilient. And here's the slide that I think sums up my points, and then we'll see if there's any questions. Here we have two individuals, and this may have resulted from genetics, it may have resulted from childhood developmental experiences, it may have resulted from the adult lifestyle. The green is the one who has greater cognitive reserve, or we'll say thickness of the tissue of the brain, and this is the one with lower. Now, by the way, I've drawn the green line above the red, but I really didn't need to. Think of the green and the red up here where it's flat as really at the same level. Okay? This is the aging process here. Now, through the slings of aging and maybe pathology or a combination of the two, this is where we get the onset of deterioration. Let's keep it simple this afternoon. Think of plaques and tangles. They come out of nowhere. I don't know why they come, but they've come. Now you have the green, who's Johnny, and you have the red, who's Bill or Mary and Jane, whatever you want, but you got two individuals up there who have the same degree of deterioration and pathology present in their brain. But here's the aging process. Now notice how red, Johnny, Jane, whatever, starts to come downhill in terms of cognitive function. That's because if they don't have that kind of biological thickness and reserve in the brain, then they soon run into trouble. The disease overpowers and actually starts to result in, my God, I was driving home from the office today, and for about 20 minutes, I couldn't remember where I was going. It happens. The other individual has the same amount of pathology, but notice how they're operating at a high level for many years. However, that's right.
Yes.
That's right. That's the negative side. You may find people through education, through genetics, through physically active lifestyle who operate at a high level. If the pathology is there, they can tolerate it, they can tolerate it, they can tolerate it, but it will be a precipitous decline once their own natural resources no longer can balance out the pathology. And people are often shocked at this. They'll say, well, so-and-so was like, a Supreme Court judge or whatever, and all of a sudden they went downhill quickly. In retrospect, that does not surprise me, but then we wouldn't really know for sure. And there's the final slide I'll put up, is that what the role of a physically active lifestyle as we go through our years may very well be, is to build cognitive reserve and tolerance or resilience to degenerative processes. It's like putting money in the bank. The term cognitive reserve describes the mind's resilience to neuropathological damage. The mind's resilience is evaluated behaviorally, like can we do math, can we go to the grocery store, etc. Whereas the neuropathological damage is at the biological level. And we can examine that by using these blood-based markers and imaging methods. And there's two kinds of reserve. My last point, Chip. Passive reserve is just the biological integrity. I'll say, to reduce it, the thickness. Active reserve is how nimble you are. And that kind of comes back to your question earlier. Active reserve is how nimble you are at using alternative networks to accomplish the same the same goal. So you want to get to Toronto, you know more than one way to get there. And if you can do that, then as one route to Toronto gets blocked, then you can go another way. But I will tell you this, that kind of compensation comes at a cost. That kind of compensation can be mentally fatiguing. This is what may very well happen, is that the brain is working hard, but you can perform, but at the same time it does not leave as much in the way of being able to handle additional cognitive burden. However, I would say that even though there's a lot to learn, and I'll leave it at that, this is one example out of many areas of human function and biology that this movement and changing our homeostasis and getting some adaptations. By the way, I forgot to say, the reason the hippocampus may be, which Carl Kottman and I talked about, the reason the hippocampus may be particularly a beneficiary of moving is because, think about it, when we moved around and we had to survive, we had to what? It starts with R. We had to remember where we went. Think about it. It's a system. We like to think of brain, body, heart because of our textbooks and all of our specialties. But the body is a unitary whole. And I think that there may be a symbiotic relationship between movement and memory for the purposes of survival. And so that's only speculative. But it may be why the memory areas of the brain, particularly episodic memory, do seem to show evidence of a benefit when animals and humans are physically active. I shall stop there.